In this lesson, I'm going to talk about sprites, and I find this actually very exciting. Code is always exciting, but making your own art for your game, I don't know, there's just something fun about that. So if you're not sure what sprites you want to make, I would suggest Googling 8x8 sprites. You have to be a little bit careful because things that are clearly not 8x8 will come up, but for the most part, they're 8x8. And you can tell, you can literally like count how many pixels high or wide it is to tell whether it's 8x8. And there's some really cute ideas out there. 8x8 is not very many pixels to work with, so the sprites are going to be pretty simple. It's hard to see. But you can, like, there's like little people with flags or swords. There's little blobby things that grow and like, it'll be like, maybe it's dying or something. There's little animals. Oh, I really liked these trees. Those aren't really sprites per se, but they might be good for background. We'll talk about that in another video. Tiles versus sprites. These are pretty cute. Anyway, so you can kind of get lost in this. There is a way to upload a sprite sheet to TIC-80, but I have found that it tends to overwrite stuff that I don't want it to overwrite. So I suggest just recreating these on your own. Another reason to recreate them on your own in TIC-80 is that the palette that we have only has certain colors. There is a way to change the palette. So this is an advanced thing. Feel free to skip over this part. If you go into Learn and then scroll down to the bottom and say Read More on GitHub Wiki, I'm just going to open that in a new tab. And then you scroll down over here on the right and it says Palette. There's information about what the palette is currently, and then customizing the palette. So there's a couple links here that you can use, the command that you would use, and a way to get the colors that you want into a palette. So again, advanced, feel free to just ignore everything that I just said. Okay, so we are in tic80.com/create, logged in. I'm going to click to start. I'm going to see what my last file was. So I'm going to load lesson 6 and hit escape, and I'm in my code. So right away, I'm going to change this to lesson 7 and sprite animation. I'm going to go back out, hit escape, and save lesson 7. And escape again. So when you're thinking about designing your sprites for animation, you want to think about some different poses that you might want. So originally I had designed mine to have an idle animation. That's a pretty common one. And then I was designing for the 4-way movement. So I have an up, a down, and a left and a right. I learned later that you don't actually need to do left and right. There's a way to flip your sprite around in the SPR function. But it's actually really easy to do left and right. So either way, you can do it either way. So some editing commands that are pretty helpful here. If you select something, you can copy it with Control-C and then paste it with Control-V. The flip horizontal is the thing that I use to make my left-right. So I just duplicated my left-looking sprite and flipped both of them, and now it's a right-looking sprite. You can hit the delete key to get rid of a whole sprite. You can use this slider. Let me make it up here. So you can edit more than one thing at a time. That will not give you more pixels to work with in a single sprite unless you want your sprite to be bigger. So don't don't be fooled thinking that, oh, I can design a more complicated sprite in here. You can, but it will be a bigger size. So just be aware of that. But it is helpful if you're trying to do an animation, so you can see more than one frame at a time. Okay, so as far as code goes, right now I have my player sprite drawing at the end of my TIC function, which means it's going to be in the very front. Whatever draws first is like literally drawn, and then the next thing will be on top, and the next thing will be on top. So by drawing my player at the end, I am making sure that it's always in the front. Okay, so instead of having my player have a static number here, I'm going to use a variable that is going to be a costume variable. So I'm going to have this be blobby.costume. Oops. But I can't just stick that in there without actually creating the variable. So I'm going to go back up to my blobby area at the top, my player sprite initialization, and I'm going to hit, I'm going to make a comma, and I'm going to say costume equals, and then I'm going to use the 256 as my initial value because it's an idle, and that's probably what my player is going to be doing when it first starts. So this sprite function is actually quite a bit more complicated than we have been using. Make my font a little bit smaller. So we've only been using the sprite number and X and Y value. So like placement and what costume is it wearing. There's actually a lot more to the sprite function. If we go to the documentation, there is the API over here on the right. And we're going to look for SPR. And then if you scroll down just a little bit here at the top, this is kind of a standard notation to explain what the inputs are into the function. So the way that this works is the first thing is the function itself, so SPR, and then you would have parentheses with whatever inputs you have. And the first input is the ID numbers. That's my 256 or whatever number of my sprite costume. And then we have the X coordinate and the Y coordinate of the upper left corner of the sprite. And then everything after that is optional. So everything in brackets, we don't have to have. But if we wanted to do a rotation, we would have to do each thing before rotation. So you can't just skip things. They have to be in order up until the thing that you want. So let's just quickly talk about each one. This first one, I think you'll probably want to use. This color key is the transparent color. So if I look back at my sprite, right now I have black as the background. That will actually draw, so this will be like a little box, a little black box with my sprite in it. Right now, I can't tell that when I run my code because my background is black. But as soon as I start putting like grass or water or dirt or whatever I have behind the sprite, that black box is going to start showing up. So in my code, I would want to come in here, and for this fourth input, I want to use the color code of whatever my background is. And I happen to have noticed in my sprite editor that if I hover over this, well, if I hover over any color, it'll tell me the number of that color. Right now, if I hover over black, you can see at the very top, it says color 00. As soon as I move, it's gonna go away, but up here at the top, color 00. Okay, so that's how I knew to put 0. You don't have to put 00, you can just put the number. And then next in the inputs, there is scale. You can only go bigger, you cannot make it shrink from the 8x8. So if you're thinking, oh, I can make a 16x16 and just shrink it to be an 8x8, that doesn't work. You can grow it and then shrink it back to its original size. So you might have noticed that there's some equal signs here. That's what the default value is. So if you don't put anything for scale, the scale will be 1. So I'm going to go ahead and put a scale of 1. And then this is where I was talking about there's an easier way to do the left-right action. You can indicate a flip. I'm going to leave it as 0 since I made my costumes have a flip already. I'm not seeing any more documentation about that, so I'm not really sure how this works. I just know for no flip it's 0. I don't know how to get it vertical versus horizontal. I'm sure there's documentation about it somewhere, but I'm not seeing it. Okay, rotate. You can only rotate in increments of 90 degrees, and you can specify that here. So I'll do no rotation, so I'll put 0. And then the last but not least, if you wanted to have a bigger sprite, if you used 4 boxes or 9 boxes or whatever, you don't actually have to make it square. You could do 3 boxes across and 2 boxes down or whatever. However many boxes you used, you would put in at the end. So, and it's just 2 more parameters here, inputs here. So if I did a sprite that was 3 boxes wide, I would put a 3. And then if it was 2 boxes high, I would put a 2. So it's width then height, however many boxes. So now I'm going to go ahead and run this, and you can see the silliness that my sprite is having here. So there's my sprite. Okay, so it's 3 boxes wide and 2 boxes high. Probably I would not do this with these particular costumes. I would have drawn a sprite that was this size if I was going to do this. But so now you understand how that works. Now that I've done all of that, I'm actually going to delete it back to blobby.y because I don't actually need any of the other stuff right now. Oh, no. I'm going to keep the 0 because the 0 is my background color. So I want to use my black, set my black to be the transparent color of the background. Okay, but nothing else. I didn't really need anything else. Okay, so now let's talk about what we're going to do to actually animate the costume. This is a little bit weird, but we have talked about some of this stuff before. So the thing that we're going to be using is mod. So you might remember this from Snap. Mod is, that would be 1 because it's the remainder if I divided 13 by 2. Not the answer, but the remainder. If I was doing 13 mod 5 would be 3 because if I divided 13 by 5, the remainder would be 3. Mod in Lua and many languages is a %sign. There's also another operator that we're going to use, and that is something that I call it double divide. I think it's called integer division. If I did something like 10 double divide 3, the answer would not be 3.3333. That answer would just be 3. So it divides and then it just chops off all the rest. So it ignores the remainder. So it's kind of like a complement to mod. Mod, you only get the remainder, and double divide, you only get the whole number part of the answer. Okay, so we're going to do some math on the blobby costume number to make it switch back and forth between the current costume and the next costume. So I'll focus on just the 2-frame costumes at first. So in order to do this math, we're going to use the time function. So let's just take a look at that real quick. And you can just watch this if you don't want to code it yourself. I'm going to be deleting this in a second. So I'm going to print time. Time starts from 0 when I start running the code, and it counts up. So let's take a look at what's happening. So here it is, and it's going super, super fast. This is counting in milliseconds. So if I was to divide this, it's just double divide, so I just get the whole numbers. I'm going to divide it by 1,000. This should give me seconds. Let's see if that works. There we go. I'm going to get rid of this. And what we want in our TIC function is actually to divide time by 10. Somebody else figured this math out, and it turns out that doing time divided by 10 is a nice way to get animation to work. So we're going to do, make a variable, t equals the time function, double divide 10. And then we're going to use this t down here. So this is where that math comes in. So we're going to add what is going to end up being either 1 or 0. So this math that we're doing, that is going to look weird and complicated, its value is always either 1 or 0. And that will let us do 256, 257, 256, 257, right? So we'll switch back and forth in between the two costumes. Or if my costume number was 283, it would be 283, 284, 283, 284. All right, so let's get that math. So it's going to be t mod 60 and then double divide 30. And magically through math, that makes it either 1 or 0. All right. So let's test this. It should be doing my little idle. There it goes. Boom. So if I wanted to test another costume, I could change this number to like 258. And there's my looking up costume. Okay. So you kind of get the idea. Whatever costume it starts out as, it will do that costume and the next costume and back and forth. If I wanted to do my slime that has 3 different frames, I'm going to still start at the starting number, so 336. So up here, just test it out. I'm going to do, and then down here, instead of dividing by 30, I'm going to divide by 20. And the way I think of this is if you do 60 divided by 30, which is not actually the math that's happening, but it works as far as like thinking about what's happening. If I do 60 divided by 30, I get 2, and that's 2 sprite costumes. If I do 60 divided by 20, I get 3, and that's 3 sprite costumes. Again, that's not actually how the math is working, but it's how it ends up. So if I run, now I have my sprite that is the little blob. So let me change this back to 30 before I forget and get all kinds of weird animations happening. 2, 6. Okay, so next let's talk about how to change the costume for left, right, jump, that kind of thing. So first thing I want to do is figure out where my move stuff is. So if we push button 2, we're moving left. Then I also want to change my costume. So I'm going to do blobby.costume equals, and then I want to know what my left number is, and I definitely did not remember that from before. 262. And then my right will be 264. So 262. So just what for you, figure out where your left-facing animation frames start and use that number. And same down below, I'll just copy and paste this, except instead of 262 for the right-facing one, I want 264. And then originally I had put in the idle costume here, but that turned out to be wrong because anytime I was not using left or right, it was overriding all the other costumes and just being my idle costume. So I'm not going to put anything here. Instead, I'm going to come down here into my up down, and if I am jumping, I wanted to use my looking up, which is going to be 258. Let me run it. You can see that I've been doing a little experimenting here. Okay, so I have my guy, and right now, if he jumps, he just stays in his upward looking jumping costume until I go left or right. Like he never changes back to idle. So it took me a while to figure this out, and it's actually just the order of the code. So if I jump first, if I test my jumping first, then I'll use my jumping costume if I need it. And then if I move this move code last, then I can do my left, right, or idle. So I'm going to put idle in here. Costume equals 256. So I'm going to cut my move code, Control X. I'm going to come down here after the jump section and Control V to paste my move code. So let's test this. So I have my left, right, and idle here. And I have my jump here. So let's see if that works. I may have put my idle in the wrong spot. We'll see. Oops. Okay, so we have jumping does not work. Left and right works, idle works, jumping is not working. Okay, let's take a look again. And that is because I overrode it with my idle. See, this is what I was having trouble with. That's why I have that many runs. I keep thinking about this backwards. So I want to put blobby, costume dot equals, oh my gosh, I'm sorry, 256. Okay, so this means first it's going to test to see if blobby is jumping, and we'll set it to the jumping costume. As soon as blobby reaches the ground, we're going to set blobby to the idle costume. So that makes sense. When he's in the air, he's looking up. When he hits the ground, he's in his idle costume. Not going to worry about doing a special costume here for falling. Down here in the move, then if I'm not pressing these buttons, I'm not going to get my move left or move right costume. It will either be a jump or an idle from up here. And then down here, as soon as I press button 2 or button 3, left arrow, right arrow, then it'll change to the left and right costumes. Let's make sure that this works. This should, I believe, work. So I'll left and right, jump. You can see him looking up, and then as soon as he hits the ground, he's back into his idle position. Okay. Whew, that took a lot of brain power for me. I want to update the slime so that when I do the slime projectile, it also does the 3 different frames that I have for it. The slime only has one like animation. It's not trying to jump and move and whatever. So I can just leave it as 320 plus T mod 60, double divide, and this time I'm going to do 20. Because 60 divided by 20 is 3, and that'll give me 3 frames. So really what's happening here is this part of the math right here is equal to either 0, 1, or 2, depending on what t is. If you wanted to experiment more with that, you could do some printing of these values and see what's happening. So let's go ahead and test that out. Okay, so let's, oh dear, 320 was clearly not the right number. I didn't double check. 336. Right. Hey, there it goes. So I can't shoot again until that's off the screen. There we go. Okay, a problem that one of my students noticed is that if we're standing still and I shoot, there's no velocity for the projectile. And it just sits there. And then I can't shoot anymore because there's a projectile on the screen. So in order to fix that, what we can do, let me see where it was. So here, where we are creating the slime by pressing the Z key, We can also double check to see that blobby is moving. So let's try and blobby dot vx is, I want to say not equal to 0, but I'm not sure how to do that in Lua. So I'm going to do greater than 0. Oh, I need a parenthesis here. Lobby.vx is greater than 0 or lobby.vx is less than 0. I want to say not equal to 0, and there's a few ways that I know and none of them worked. So all right, so projectile. I'm trying to fire my projectile, it's not working, but now it is. All right, let's make sure we don't forget to save. So I'm going to go ahead and hit escape. I'm going to save lesson 7. And then we're going to download it using the get command so that we can save it outside of this program so it's safe. I'm going to use the get command. It's lesson 7, and then when you're downloading, you have to give a file extension, the same one that's listed when you do the ls command. And then when you do this, it should automatically download into your downloads folder, and you should drag it into your Google Drive. I'm going to have to click save for it to actually save, and then I can show you real quick. Remember, when you do ls, there's .tic. You can also save these as .lua. That is just basically like a text version. And the .tic is something that TIC-80 understands. So I would just do .tic unless you have a reason not to. All right, that's the end of the video. I hope that you come up with some great animations. Can't wait to see them.